Okay. So next one, output impedance. See the output side. What all resistance you have at the output side? What all resistance you have at the output side? Yes, I have marked the output side of circuit. See and say what all resistance you have at the output side. I think you want me to pick up the name and ask you so that you will answer it right. Srivatsav?
Yes, sir.
Yes, what all resistance you have at the output side?
RC.
Only RC? I can find one more resistance there. You are finding only RC? Can anybody say what is other resistance available there? If anybody says the answer, your assignment mark is 40, full marks. I am giving one-time opportunity for you. I can find two resistance at the output side. One resistance, as Srivatsav told, is RC. What is the other resistance?
HFE, sir.
What is HFE? HFE is current gain, right? So how can you say that as a resistance? What else you have in the output side?
RL, sir.
RC is your RL. Your load resistance is going to be your RC. So RC and RL are same here. The output side other than RC, what you have? Other than RC in the output side, what you have? You have a current source, right? What is the impedance of current source? What is the resistance of current source? Any voltage source or current source, it will have its own impedance or resistance, right? So what is the value of resistance for voltage source? What is the value of resistance for current source? If you say the two answers, your answer is solved here. See, here they have given output impedance is directly equal to RL, which is equal to RC. But how we are getting that, you should know, right? With blindly, we cannot write is it not equal to RL or is it not equal to RC. How we are getting that? That is a question. For that only, I am going to try to explain you the answer. What is the impedance of current source? You should have studied this in basic electrical engineering. All these will come there. Nobody knows the answer. What is the impedance of current source? An ideal voltage source, remember or note this somewhere, an ideal voltage source will have an internal impedance of 0 ohms. An ideal current source will have an internal impedance of infinity ohms. So if you are having an voltage source in your circuit, if you are going to find the impedance, you have to consider the impedance of the voltage source as 0. If you have a current source, you have to consider the impedance of current source as infinity. So now this current source can be considered as a resistance with value infinity, correct? Anything parallel, and this current source and RC are in series or parallel? This current source and RC are in series or parallel? Current you apply is splitting here, right? So the current source and RC are in parallel. So what is the impedance of current source? Infinity. What is the impedance here? RC. Anything parallel to infinity is RC. That is how you get the answer as RC here. You cannot blindly write RC at the output side. How we are getting the output resistance as RC? Because it is RC parallel to infinity. How did this infinity come? Ideal current source will have infinite resistance. Is it clear how we are getting the output impedance value? You have to always consider the effect of the current source here. If this RC is not there, can anybody say what is the output impedance? Output impedance? If this RC is not there, can anybody say what is Z not in that case? So
0, sir.
nobody. If RC is not there, what is the only component you have in the output side? What is the only component you have in the output side?
Current source, sir.
What is the resistance of current source? I told you.
Infinity.
Infinity. Just a second, just a second. So it's going to be infinity. Okay, so it is going to be infinity. So infinity means it is going to act like an open circuit, right? Okay, so when you don't have a resist, when you don't have this RC, the output impedance will become infinity. Okay, the output impedance will become infinity. So just I'm giving you all these options and seeing and saying you what is the effect when RC is there, when RC is not there. So in some circuits, RC will not be there. In some circuit, other than RC, you will have one more load resistance also. So in that case, you should be clearly knowing how to find the output resistance. So I think this part is clear.